Hello. This is the first lecture for ECO 420W. So I'm using the slides provided by the textbook. So I'm going to follow the slides very closely. And as you see, I made a banner using the logo. Uh, so I enjoy being a YouTuber. So let me start. This slide consider it is about just the introduction to the materials and review of statistics and probabilities. So I assume that you have taken 320. Of course, it's a prerequisite. You should have taken that. If you have not, so if you have not taken that, you are not eligible to take this course. So uh, it is just a brief review what we are going to do. Let me start. So what we are going to do. So basically, this is a statistical method. The course is for statistics for economists. And you have taken micro, macro, and many other economic theory classes. The problem here in there is, say, they tell us the intuition, how the market works, how the prices are determined. For example, when there is a tax, additional tax will increase the price and reduce the quantity traded. So, okay, that's important conclusion, and you need to understand why that happens. But in practice, what is missing there is then how much. We know that increase in tax will increase the price. Then how much? So in many cases, the how much is the most important question. Suppose that you are a policymaker, you have to design the uh, tax policy. Then like you cannot just say let's increase the tax. You have to say how much. So then what you need to do at that point is to estimate to look you need to look at the data and estimate the exact magnitude of that effect. So here are examples, and these examples will appear again later as examples for more statistical to explain the statistical methods. So first, what is the quantitative effect of reducing class size on student achievement? So everyone knows that if you had a if you have a if you learn in a very small class, then you will do better. Your understanding will be better, and you may ask more questions. The teacher can focus on each of the students better, so it will be better. But how much? How much is an important question because reducing the class size uh, requires money, additional funding. So then its effect worth the money. So that's quantitative analysis. And second example, how does another year of education change your earnings? So if you get a master degree, which takes 1 year, for example, then how much will it increase your salary? So you have to estimate that. Everyone knows like higher education will likely to increase your salary, but how much? So, and to make your education decision, uh, you better have a better estimate for that effect. And third, what is the price elasticity of cigarettes? So you learn price elasticity from microeconomics. The elasticity is important determinant of the tax rate, optimal tax rate. So when you set the tax on cigarettes, you have to understand elasticity. So if the elasticity is low, then higher tax is justified. The optimum is the higher tax. But if elasticity is high, then any tax will result in a huge loss of welfare. So that's what you learned in microeconomics, but you have to complement the theory with quantitative analysis from data. And fourth example, what is the effect on output growth of a 1% point increase in interest rates by the Fed? Very interesting and very important question. So these days everyone is looking at what the Fed is going to do and guessing when the stock market may go up or not. And of course, the Fed has a huge group of researchers working on this topic, similar topic like basically this topic. What is the effect of a policy? What is the effect of a change in interest rates? So we know increase in interest rates usually have a negative impact on output growth, but how much, right? That's a very important and big question these days. And finally, what is the effect on housing prices of environmental improvements? So if you build a new park, Central Park, in say in Niskayuna or like Schenectady area, then would it improve the housing prices? Yes, it would, but how much? So then you have to. So in these examples, clearly, answering to these questions is an important part of decision making, policy making. So then that role, so decision making relies heavily on not only on economic theory but also maybe more importantly on data analysis, how you extract those information from data. So that's this. In that sense, this is why we have econ department has its own statistics and econometrics classes. And ideally, the best way to answer those questions is to experiment. If you can do experiments on, say, interest rates, then you can study everything. So let's see what happens if we increase the interest rate by 1% point. Or, okay, then go back, reload, save and reload to go back to the last year. And what happened if like say if we lowered the interest rate even more than what we did? So if you can repeat those kind of experiments, then you don't need this course. Just it's a matter of time and money doing the experiments. But of course, it's not possible. It is not possible in most social sciences because of money, mostly because of the available funding or ethical reasons. So you cannot experiment with interest rate will have too a large effect on everyone's economy, so no one can accept it. Also, it costs a lot of money. You have to compensate the effects, then it's impossible to do the experiment. Similarly, like even a smaller size experiment, like let's experiment with class size. If you increase a class size, then what is its effect on test scores? But the problem is, can you do it? Randomizing class size, like enlarging or reducing class sizes, uh, is not allowed by the rule or by the policy. The policy cannot be changed that easily. Of course, there will be a lot of complaints from parents if your like children are assigned to larger classes. Everyone would like to have smaller classes, but it's not possible, like for political reasons. So then, what can we do? So we assume there is no experimental data. Experiments are not possible for some reasons. data are not available, then we have to rely on observational data. Observational data is a term used as opposed to the experimental data. You don't have experiment, but you observe something. You observe class sizes, test scores, then you have to get something out of it. And like it applies to all the questions I showed before, right? Returns to education. You cannot randomize, you cannot experiment with your education. It's you live your life only once, so you cannot do any experiment. But you observe other people, and all the people have different levels of educations, and they have different salaries. So then you may be able to extract some relationship from there. And cigarette prices, similar. Different states have different taxes on cigarettes, across states or over time. So you can see the effect of the variations in taxes. Or monetary policy, also you observe a variation over time in interest rates. Then what was the effect of that interest rates? So these are not experiments. They are the like tax rates or interest rates or educations are deliberately chosen by the decision maker or the policy maker, and we just observe their outcomes. It's not a perfect experiment. Still, we would like to do something, and that's what this course is for. In this course, I'm going to show you the basic models, basic methods to handle observational data and obtain some meaningful result. And I will also tell you the cautions, what you have to be careful when you handle typical errors and typical biases problems you may encounter in handling observational data. So it comes here. There are many difficulties because arising from observational data. So the difficulties because you are not using experiments. If you had experiments, you would not face these difficulties. But because the experiments are not possible, you have to deal with some additional problems. For example, confounding effects. So it's more academic term, statistics jargon, but basically it's about omitted factors. Or imagine like this. Your education and say the class size and test scores. The relationship between the class sizes and test scores are both affected by their family background. Like if a student's parents are highly educated, or the parents are more willing to educate willing to spend more time and money on their child's education, then these kind of unobserved factors play an important role in determining both variables. Class size, if your parents are rich, for example, then they will try to send you to a school with smaller class size. Also, at the same time, will do they can buy more books or may hire tutors to improve your test scores. So what we don't observe is an important factor in determining both observed variables, and we call those hidden factors as confounding effects. And second, simultaneous causality. So simultaneous causality is something like this. Think about this. Returns to education. When you think about returns to education, we would like to estimate the effect of education on salary. But you may go the other way. Say, you expect you are going to have enough salary in the future, so you can afford higher education. It's like reverse causality. So education affects salary, but like if you knew you would have low salary, then you had to give up the education. So salary affects education again. So it kind of cyclical effects, and it contaminates the data, causes problem. And finally, correlation does not imply causation. So correlation is what we observe. So it is easy to see from the data that there is some kind of pattern, like positive relationship or negative relationship between two variables. But from there, we cannot conclude they are causing one another. One is causing the other, or so. If the clear pattern, even a very clear pattern, does not say these two variables have cause and result relationship. That implication is so concluding causal relationship is very difficult. It's not only about data analysis, but also you need to look up economic theories. So anyhow, the point here is there are a lot of things we have to be careful, and we need to consider many potential problems when we handle observational data. That's the final goal of this course, what we do in this course. Okay, I will continue in the next video. Thank you for watching.